our next presenter doesn't need an introduction. He's an old friend of the Global Innovation Field Trip, but we're going to ask him to introduce himself because I always enjoy listening and to his introduction and knowing who he is. So from the United States, state of Ohio, right?
Correct.
Bruner. So welcome, amigo, and go ahead.
Gracias, Arturo. And it's good to see you again. And Ernesto, it's wonderful to meet you for the first time. I am, in fact, Jim Bruner. I live in Columbus, Ohio. And it's really important that kids all around the world know that not only do I live in Columbus, Ohio, I live in downtown Columbus, Ohio. And this backdrop behind me is my yard. I live 10 blocks from our state capitol. And I work for an educational nonprofit here in Columbus that is national, and they do international work as well. It's called the PAST Foundation, and my job there is the Sultan of Systems. That's my job title. And basically what I do is I help kids, very much like Malachi, invent the future by giving them problems to solve and giving them skill sets and challenges that they need to come up with answers for, because that's the world they're inheriting. And it's not enough to think you know what you need to do. It's really important that we have young minds, again, like Malachi, who not only see the problem, but know that the first solution isn't the most appropriate solution. It's generally going to be the third, fourth, fifth iteration, and you're never going to do it alone. So I thought, Ernesto, just to piggyback on you for a moment, I thought your question to Malachi about what his friends thought and the insights that came from those questions was a seriously good question. Because a lot of times kids don't self-reflect on who they are and what they're doing. And they don't see a world bigger than their nose or their home or their town. And that's one of the things I love about GIFT, is this truly is the world. So I don't know who's listening to me. And I love that. So today I am going to be presenting part 2 of my original presentation that I did last year on the project that I worked on all summer called Project Martian. May I share my screen? Okay. And here we go. Arturo, give me a thumbs up if you can see that.
Yep. All right.
Rock and roll. Okay. So basically, Project Martian was my frustration with COVID. I had planned an amazing summer camp for middle and high school students to work together as mentors with each other around urban agriculture. And then COVID came and the summer was lost. So I had to do everything myself, which is really difficult to do. So I invented a series of machines and robots to do it for me. And this year, I actually will get to work with kids. So I'm taking all of what I learned from Project Martian last summer and revisiting it, the technology around the bioreactor, and I'm introducing robots, coding, and assistive devices and data to the mix. And it's basically Project Martian Bioreactor is the name. So without further ado, I'm just going to get into this. So last year's project, this is a recap of what I presented last year. My proposal for Project Martian was, we need to grow food quickly. And I created, in my one garden here in Columbus, Ohio, 1/3 of an acre, I created 9 metric tons of compost on my own using this system. I want to take you a moment and I want you to think about what 9 metric tons is. That is 8 Ford F-150 pickup trucks full of compost. And I collected that mostly here, but I also collected it in 39-liter, 10-gallon drums with lids that locked from all my neighbors. And I just told them, this is it. I need your grass clippings in one. I need your leaves in another. And if you have food, I need that in a third. Tell me how many you need. I will drop them off at your outpost and pick them up. And I picked up 7 of these 39-liter buckets every time I sent my rocket out and brought them back. I layered them in this device, which is called an intermediate beverage container, IBC. It's 1,000 liters, 1 metric ton when it's filled with water. It weighs 1 kilogram, or 1,000 kilograms, I should say. And for all my friends around the world who don't live in America, this will be obvious to you. But for most American children, this is not obvious. So this is 2/3 ton, basically, American Imperial. And I layered it in brown, green, brown, green, brown, and I mixed water in with it. And in my proposed system, we would fill these compost, 1 metric ton of compost on Earth dry and ship that to Mars. And when it arrives on Mars, the Martian outpost there, all robotics, would start synthesizing hydrogen and oxygen out of the atmosphere into water, H2O. And then those water IBCs would be placed on top of the compost, and then it would be accelerated with 10 liters of ammonia, yeast or ethanol, which is basically beer. But I made it so I could use brewer's yeast rather than beer, because I recognize that most kids aren't going to have access to beer. But beer is an excellent accelerant. And then syrup, like maple syrup with water or just cola. And I had that ferment. And in the IBC, I had basically a stirrer, a solar-powered stirrer that stirred the compost and this liquid all together over time. And I did the math, and I realized for every colonist, there would have to be 9 of these bioreactors to produce enough soil for use to grow food for them on Mars. And that's 9 every 21 days. And this is what the compost looks like. You can see the boundary between the aqueous clay that comes standard with property in downtown Columbus that has had houses built on it for 150 years. It's clay and compressed. This is the bioreactor composite. 21 days of processing in my bioreactor. This is 30 centimeters of compost. And what's left after you drain the fertilizer is 30 liters of compost. So that's why you need so many of them, because it doesn't make a full 1,000 liters because of entropy and science and chemistry. You lose 2/3 of what you create, which leaves 30 liters of usable, growable dirt. And so with that, these beds here, these square beds, I dug them all up by hand last summer, 30 centimeters deep, which if you don't use metric is about 18 inches. And I replaced it with this compost, which is absolutely rich. And so that was a very, very interesting experiment, and it worked beautifully. If you see the last gift, which I think was in January, you can see how well I did with that. It grows food remarkably well. So this year, I thought, well, let's go to the next level, very much like what Malachi did. If that worked, what if I imagined my property, and this is an outline of my property in Columbus, Ohio, what if I imagined it under a dome, pressurized to 1 millibar of atmosphere on Mars? And what if I took the compost that I developed and I mixed in about 10 liters of Martian regolith, which is really sharp and will kill any living organism. Because if it's a small organism like a bacteria or an insect, the regolith is super sharp and it will cut through the shell and the cell wall of the bacteria. So I needed to figure out a way to mix in the regolith with the compost so I could extend my growing medium and use what I have on Mars. So on Earth, I used life forms that are called diatoms. And the diatom has a very sharp shell and it functions very much like Martian regolith. I said, well, why stop there? Why not use the entire property? So what I ended up doing was I created 4 robots. I created a central computer that lives in the cloud, which is my Raspberry Pi unit. And then I modified 4 remote controlled robots with a Raspberry Pi Zero sensor. One of them is designed to fly through the air of Mesocello around the trees. One of them is designed to swim in the aquatic ecosystem at Mesocello. It has a camera in it, a motion sensor, a temperature sensor, and a nitrite sensor. So it monitors the health of my pond. The airbot, which is the one that flies, monitors the life in the trees, monitors the health of the trees, and monitors the pressure at what would be the top of the dome to make sure there are no leaks. Then I have the ground bot, which follows a predetermined path around Mesocello to look at places that are weak points that need to be checked regularly. And it has a camera and an additional Raspberry Pi unit on it for mobile processing across the entire colony. And then the last one is a tiny little tank that goes under the earth and checks. It has the same kinds of sensors on it: temperature sensor, pressure sensor, motion sensor, and it has a pH sensor, so it can test the soil to make sure the soil is healthy. And you might be asking what this little white square is at the bottom. That is my test. It's called a tile, and it's a radio frequency ID tag that I have 8 of them that I put all around Mesocello, and I've programmed the Zero Raspberry Pi unit to respond to those tiles. So I can program it to go to that tile and check. Tell me what the altitude is, tell me what the temperature is, moisture, what the light is, what the pressure is, what the pH is. And this is all important because they're deployed all over the colony, from a central control unit in the back behind where I keep my chickens and my rabbits and my hens or my ducks. All of these sensors go to different places. Arturo, how am I doing on time?
Yeah, we're doing fine. We still have a couple minutes.
Okay, great. So this is my aquatic ecosystem. And last summer, I made the case you cannot go to the moon or to Mars without an adequate source of water or protein or algae in your colony. So this is a 2-meter deep pond that is consistently at 21 degrees Celsius. And at its deepest point, it's 2 meters, and it's filled with fish and a robotic net that I can catch the fish with. I need to monitor the health of this pond. It is mission critical to the colony's life. So I bought a remote control shark, built a Raspberry Pi Zero unit in it so it can be remote controlled from my base station. And there is a waterproof tile on the wall of this pond that it always goes back to so it can sync information with the Raspberry Pi control unit. Next is the airbot. And the airbots launch off my pergola and off these 2 gates in my yard. So they don't land on the ground. They always stay at a consistent 2.3 meters. So I can guess how high I am and know it launched from here, and I don't have to launch from the ground because the drones fail when you launch from the ground because of ground effects. So I launch midway to the top of the dome, which is 15 meters. That the airbots fly a specific path, and you can see these paths when you look at this illustration here, the green path is the ground bot, the purple path are the air bots. And this will all be available on the gift website and on my website. I'll share the URL with you when I'm done. This is the ground bot, and it is basically a remote controlled Raspberry Zero controlled vehicle with a portable computer and motion sensor on it to capture life forms that come into my garden at night. It takes pictures of them as they move. So I not only know what's there during the day, this system can run at night. Everything is charged by solar, and it just goes to its tiles and takes pictures. And in this particular photograph, you can see my Martian beds. The 30 centimeters of compost are covered over with burlap, and I cut into the burlap. And this is how I overcame the diatomaceous earth issue. When I cut through the diatomaceous earth, I push it away. So anything coming up can only grow where I cut, and the diatomaceous earth or the regolith doesn't cut it. Anything trying to grow down gets cut. So if it's an insect or a weed, the diatomaceous earth will kill it. But anything growing up underneath it can't be killed. That was my solution. And these white boxes in front of you, it's a waste of space and energy to grow greens in the ground. It just isn't very efficient. So I put Martian compost in these boxes, and there's a pump that circulates water through them. And there are 12 of these all around the perimeter of the garden for all my greens. And it increases the amount of yield I can get in that 15 square meter box by 60%. Makes perfect sense to do it that way. And it's all run by solar. This is the Molebot. This is how I determine the health of the soil. At the top, you see the green tube with the white tip on it, not the one in the ground, but the one sticking up. The tank enters that and goes down into the tube, and the tube has cutouts in it with netting to keep the dirt from coming in, but allows the life to enter the tube, allows the pressure and heat to enter the tube, and most importantly, allows the roots to enter the tube. So the Molebot, which also has an array of sensors on it, can determine how healthy that particular soil is. And I have more pictures of that if you want to see them, but this is going to be sweet, sweet, sweet when it's done. This is the entire Martian colony of Mesocello, and you can see the 8 ecosystems that comprise the ecosystem that is under the dome. And I have circled here where the original bioreactor project was, 2 IBCs stacked on top of each other with a circulator and under pressure. The water was always under pressure. It always stayed at 1,000 liters. So it would continuously pour at the same rate. That's how I controlled it. You really should go back and look at my other presentation. But in this domain, I grow different kinds of food and different kinds of green and brown bioorganic material for the biocompost, because you don't want to eat all your food. You're going to need some greenery to produce oxygen, to give you shade, to give you beauty, and to feed the other organisms that require other ecosystems other than the ecosystems in your garden. It's a fable that we're going to live on Mars and just grow food. It's not possible. Life will not sustain itself on one ecosystem like that. It just won't. We're thinking very, very short term if we think we're going to build greenhouses that only grow food. Life requires other forms of nutrition and nourishment, and so do humans. You need trees. So you got to grow a few trees if you want a healthy system. And that is my presentation. What would you build on your Martian colony? That's what I want to know. So do I have any questions?
Wow, Jim. If your presentation in the past gift was inspiring and interesting, this like next edition is amazing. It's great, like now to see about those things that you said about the control and the robot integration, and those the those changes that you make with the boxes and all of those considerations. Um, this project, I mean, for me is something that awes me like all the time. I have been asking you about it like in the past. I have a question here.
Yeah.
Um, this like I want to perhaps calling it facility because it's your home, but all of this installation here, do you get and visitors? I mean, it's pretty much like a a place where learning doesn't stop and all of that. I mean, I don't know if you actually do tours around that for people.
Well, originally it started out as a passion project for me because I think, Arturo, you know about my health condition. And it's very important for me to have access to fresh food, and I can't always afford it. I can, however, afford to grow it. So my motivation for growing healthy ecosystems is primal. I mean, it's really important to me. This is a learning lab. This is a learning lab of the Past Foundation. And I can say for the first time, I have a large grant from the Ohio Farm Bureau to prove this proof of concept. They want kids working on these out of the box ideas about not only how you grow food, but how you grow healthy ecosystems and places to live in food deserts. Because I live in a food desert. I literally live in downtown Columbus. I'm surrounded on 3 sides by asphalt. So I am literally in a food desert. There is no grocery store close to me. The closest grocery store is about 8 kilometers away. I can't walk it easily. I have to drive there. If I couldn't drive to the store, I would have to go to a gas station and eat substandard food. And it's really important to me that kids understand the brain is a chemical, emotional, bioorganic computer. And when you feed it faulty food sources, it will give you faulty readouts. So you eat crap, you will think crap. It's really important to have a healthy diet. And I believe this ecosystem and this idea of reframing Mezzocello as a unique colony will really get kids thinking, what would I do if I had a constraint? If my whole world was a half an acre in a crater under a dome, pressurized on the moon or Mars. And outside that dome is zero pressure, explosive vacuum, and negative 230 degrees Celsius. Oh, and don't forget about the polarizing UV radiation and cosmic rays that will destroy you. So that's a stressful situation. And I lived in this garden behind me through COVID with very little side effects, emotional and panic side effects, because I live in a beautiful colony. And I realize people need beauty. When you deprive people of the opportunity to experience and be part of beauty, you remove part of their humanity and part of their ability to learn and empathize. We can't love in an ugly place. It's not possible. And in order to build a colony that's going to support life in a place that is so hostile, the very first thing you need to build is love, beauty, empathy, and safety. So that was my thought. And the second thing you need to build are killer engineers that can solve any problem, any crisis. And that's why I started with the RC controlled toys, because it was really easy to overwrite the IR signals that they get from the radio control module with the zero. And whatever they want to do, they have to program it in Scratch, and then it does it. There is no remote control. I'm not using any remote control devices. These kids have to program where they want these robots to go. And then it sends it. And it sends it, ironically, from the top of the dome, which is 15 meters above my ground. And it hangs from a tree, and it's literally that Raspberry Pi, a Wi-Fi adapter and repeater, and a hotspot. So every signal they send, not only do they need to know where that hotspot is, they also need to figure out the angle of theta from their device to that hotspot and what's in the way. So I'll have these kids, their brains will be hot this summer. They'll be thinking hard about this, but I mean, my camps are full. 24 kids each camp. They're totally full.
Wow.
I don't know how I'm going to do it, but I know I am.
Let me
Now, with
tell
all
you.
of the data that you're going to get from the sensors, have you thought about putting real-time data? Because, I mean, it could be a chance also of involving people like from other locations to keep an eye.
Can you keep a secret?
Yep.
I'm going to share that data with Gift. And one of the things I want the kids around the world to do is help me create a 3D simulation of mezzocello so we can start doing experiments online with it. I'll have all that data. And I have other plans for that data. And that data is paid for by a grant. So I have to share it with my grantee as well. But I do want to share it with the world. I want to give the whole world an ecosystem 5 meters deep and 15 meters high and 50 meters wide by 50 meters wide. I think that would be a fabulous simulation because I can give real data on all of that. And the kids will be collecting it as a side effect of what they're learning around coding. So why not?
Let me tell you something, Jim. It's nice to meet you. So this is my second time being a panelist in the GIF. So I'm really impressed with you and your initiative. So this type of initiative, I really love it because this kind of initiatives help us not only to see local solutions, but rather to have let me tell you, like an interplanetary vision, if I could
Absolutely.
say so. So this allows us to analyze solutions that organically integrate human and any kind of technology. So we can use it in any kind of ecosystems, being here in the Earth or in Mars or maybe in the Moon. So this kind of initiative is really, really amazing. The kids, you are absolutely right when you are integrating the kids to this kind of solution because they are the future. So basically, what you are doing right now, maybe some kids like Malakia will be doing maybe in 10 years from now.
One of the things I'm most excited about this, Ernesto, actually, is a very hard lesson I had to learn about. This garden is now 7 years old. In my second year, I created precious things. I call them precious things. They were things that required a lot of water, things that required a lot of time, and they only gave me one thing. That's not sustainable. Every system at Mezzocello has to have at least at a minimum of 3 inputs and 4 outputs. If it's not giving me 4 things that I can use elsewhere, it must go. It's like the pond, for example. It gives me beauty. It gives me water when I need it. It gives me protein in terms of the fish. It gives me the algae that I can dehydrate and use anywhere. And lastly, it gives me a place to keep my animals healthy because they always have access to fresh water. And all I have to do is keep that healthy, which requires a robot to monitor it. And a robot in the biofilter to make sure that all the ammonia and nitrite levels are right. Same thing with those garden beds. Multiple inputs, multiple outputs. I want kids that are going to be living on colonies whose whole lives depend on that garden to understand when you design something to do one thing, you've designed a point of failure that will be your doom. Do not think that way. You must think holistically. And if I accomplish anything this summer with the bioreactor project, it's getting kids to recognize not just a tool for one thing. It has to do multiple things or it's not worth sustaining.
Yeah, that's
That's
right.
it. That's a web. A
Yeah.
web has multiple strings. And I have to stop because I'm picking up all the time. So
So we are on
Amazing, Jim.
schedule.
Yeah, we're right on schedule. Yeah, but thank you for sharing this. We are definitely looking forward for the next part, the results, the next success of your of this project. Gives me an excuse to go over to Columbus and pay you a visit.
love that.
So I hope that the conditions allow me to travel soon. So
Indeed.
thanks, Jim. Thanks for sharing
Thank you.
this. Thanks for being here.
And thank you to all my friends around the world who are watching this. I'm proud of all of you, and I'm so honored to be here with you, presenting with you, and learning with you. Much love.